Hi everyone, today's class we are going to discuss about the basics of engineering. Let me move towards this slide. So in basics of engineering subject we are going to discuss about the instrumentation topic. So what are the topics we are going to discuss in today's class? So we are going to discuss about the functional element of an instrument. Then we are going to discuss about the error. Then what are the applications of digital meters, then single phase energy meter, then finally the advanced topic, advanced metering infrastructure. So these are the topics we are going to discuss in today's class. So first we move towards the topic functional element of an instrument. So before we are going to discuss about the functional element of an instrument, we should know what is instrumentation. Okay. So here the instrumentation is mainly focusing on measuring purpose. So if you want to measure any data, we are going to use an instrument. So this instrument is further classified into two types. One is direct measurement and another one is indirect measurement. So direct measurement means you are directly measuring the data. For example, if you want to measure a length, then you will be using the scale, ruler, and you will be measuring the data directly. In indirect measurements, you will not measure the data directly. So you will use some related parameters to measure the data. Okay. For example, if you want to know the speed of an object at a particular at a known distance, then you will be relating the time. Okay. By measuring the time with the known distance, you can able to calculate the speed of an object. Okay. So this is the indirect measurement. So in measuring, we are classified that into two types, direct and indirect type. Okay. So how we are going to measure the value indirectly? Okay. For that only we are going to discuss. Okay. So the entire measurements cannot be made directly. Okay. In engineering purpose, we can't able to measure it directly. So most of the values are measured by indirect methods. Okay. How we are going to do that? Okay. So what is the functional element of an instrument? Okay. So here we told that we are not going to measure directly. Okay. So if you want to measure some any physical quantities like temperature, pressure, any physical quantities, then we need to convert into some other parameters. Okay. Normally we will prefer in electrical form. Okay. So for that we will be using a sensing element. Okay. So in the slide you can able to see primary sensing element. What is the purpose of the sensing element is you want to convert this physical parameter into an electrical form. Okay. For that we are using the sensor. Okay. Normally we will be using sensor or transducer. Okay. This is the primary contact for. Okay. So if I want to measure some unknown value, okay, the initial contact with that unknown value is the sensor or transducer. So this is the primary sensing element. So this is the first element of an instrument. Then the second one is data conditioning element. So once I measure the value, sense the value, okay, then I want to process the data. How I am going to process the data? What is the necessary of data conditioning? Okay. So the first one is if my processor is a digital one, okay, but what the sensing data is an analog one, okay. So for the processing, I want to convert this analog signal into digital signal. Okay. For that, I need to have some conditioning. Okay. So that is the data conditioning purpose. Okay. So in data conditioning, it will be changing the signal from analog to digital. That is one type. Then if the signal is very weak, okay, so if I am sensing some signal unknown value which is very low value, with that low value I can't able to measure it. Okay, for that I want to do the amplification. Okay, so that is also data conditioning. Okay, so I will use an amplifier to amplify the signal, then I will process the data without changing the original value. Okay. That is the data conditioning elements. So in data conditioning elements, we will mainly transfer the signal from analog to digital, or we will be amplifying the signal. Okay. So they will be amplifying the signal before processing or after processing, okay, based upon the structure. Okay, this is the data conditioning element. The last one is data presentation element. Okay. So data presentation means how you are going to present the data, whether you are showing it in a CRO, cathode ray oscilloscope, or you are showing the data in measured data in digital storage oscilloscope, or what way we are going to show the data. That is the thing we are seeing. We will be seeing the data presentation element. Okay. So these are the functional element of an instrument. Okay. So in data conditioning element, we are conditioning the data. Not only we will conditioning the data, but we also manipulate. Okay. So I forgot to tell. Okay. So data conditioning will conditioning the data, and it will also manipulate without changing the original value. So why we are going to manipulate means just what I have told, amplification, and like that it will manipulate the data. Okay. So that is also the key function of the data conditioning element. So for any value going to be measured, you need to have these three basic component or functional elements. That is primary sensing element, data conditioning element, data presentation element. So here we are going to see an example how the Bourdon tube pressure gauge is used to measure the pressure. Okay, so the picture you can able to see the Bourdon's tube. Okay, so it is the tube which is going to measure the pressure. Okay, so you can able to see the pressure source. You can see the pressure source which will giving to the input. Okay, so the other end of the Bourdon's tube is closed. Okay, so the applied pressure will be going to the Bourdon's tube. Okay, once the pressure is given into the Bourdon's tube, there will be some displacement will be there. Okay, because of the pressure. Okay, so we are applying a pressure, then there will be displacement will be there. That displacement will be linked to the mechanical linkage. Okay, so the mechanical linkage will be directly linked to the displacement. So based upon the displacement, the pointer will be moved. Okay, so the pointer is attached to the mechanical linkage, which will be moved based upon the pressure. Okay, from that we can able to calculate the pressure. So it is an indirect way of calculating the pressure. Okay. So you can able to see in detail. So here there is a water flow is there. So if you want to measure the pressure of the water flow, I am attaching the Bourdon's tube. Okay, you can able to see when the pressure is increasing. Okay, so the increasing pressure will flow through the Bourdon's tube. Okay. So because of the increasing pressure, there will be some displacement will be there. So because of the displacement, it is directly connected. Can you able to see the gear type of arrangement? Okay. So here you can able to see the gear type of arrangement. This is manipulation. So what previously we have discussed, amplification or manipulation. So it will manipulate. So it will increase the displacement so that we can able to see in the pointer value. Okay. For that purpose, the mechanical gear arrangement is used. Okay. So this mechanical gear is directly attached to the end. Okay. So that when the pressure is applied, there will be some displacement. The displacement will be linked to the gear arrangement. So that the gear will increase the manipulate the data, and it is coming to a pointer. Now the pointer will move. Okay, based upon the displacement. In such a way, we can able to calculate the pressure. Okay, this is one of the example of functional block element of an instrument. So this is the functional element, the total block diagram. You can able to see the quantity going to be measured. Okay, so the first component which is in direct contact is the primary sensing element. Then variable conversion. So what I have told. So it may be an analog signal or a digital signal. You want to convert it into an digital or analog. So there will be conversion system will be there. Then manipulation. So you will manipulate the value without changing the original form. Okay, that is you will manipulate the data. Then in some purpose you will transmit the data. So if it is a longer distance, for example, if you take a substation, okay, from substation you need to get the data to some other places. Okay. So you will be transmitting the data. Now the latest technologies that are IoT like that, you will be transmitting the data. Okay. or smart meters. The smart meters will transmit the data to the data center. Okay. That is the purpose of data transmission. Okay. So data presentation, what we have discussed, it will be an cathode ray oscilloscope or a digital storage oscilloscope, any display device. Okay. That is the data presentation element. So this will give an outline of how we are going to measure the value. So what is the process going there when we are measuring the value. Okay. So this is the first thing we have seen. Okay. Next, what we are going to see means, so we have measured the value, whether the value will be accurate or whether the value will be precision. Okay. What I want to insist here is, if you are measuring in a direct instrument, error will be very, very less because we are directly using an instrument and we are measuring the value. Okay. So the error will be very, very less. But if you take an indirect measurement, we are indirectly measuring the data. Because of that, error will be there. Okay. So now we are going to see what are the different types of error. Will be available commonly in any measuring instrument. Okay. So there are three classifications of error available. Okay. So first we know what is error. So error is the deviated value. Okay. So if you want to get an accurate value, there will be some changes in the accurate value. That change from the accurate value is known as an error. Okay. So this error is happening when we are measuring and valuing the instrument. So different types of error. First one is gross error. Then second one is systematic error. Then third one is random error. Okay. So this is the classification of errors. So first we will see what is gross error. So gross error, it is nothing but a human-made mistake. Okay. So when you are taking the readings, okay, if you are wrongly enter the data in your observation, okay, then the error will be happening. For example, if the reading is 31.5, okay, by mistake you are writing as 13.5, okay. So this is the gross error. It is mainly based upon the human mistake. Okay. So you can able to see it is a human mistake in reading an instrument and recording and calculating. Okay. So what example we have seen? Okay. Instead of 31 point, the actual reading is 21.5 degree, but while reading the temperature, you will be reading as 31.5. Okay. Or maybe reading as 25.8 degrees Celsius and recorded as 20.5. Okay. So a careless mistake. Okay. Because of this careless mistake, the error will be happening. This type of error is known as gross error. How we can reduce this gross error? Okay. So we need to take two or more readings. Okay. To avoid this gross error. Then care should be taken. Okay. So while doing the experiments, you should be with a great conscience and you need to take the readings. Okay. Then we can simply avoid this type of errors. Next is systematic error. The systematic error, it's the most important one. Okay. So the first one is because of the human. Okay. Human, when he is measuring the data, he is recording the data in wrongly manner. Okay. That is the gross error. Okay. Now systematic error. So how the systems will make the error? Okay. So there are three classifications. Okay. So first classification is instrumental error. Okay. Because of an instrument, there will be error will be happening. Okay. Then environmental error. Okay. The instrument will be working in good condition, but because of the environmental nature, error will be happening. Then the last one is observational error. Okay. So because of an observational reading, okay, it is similar to the gross error. Because of the observational reading, the error will be happening. This is the observational error. So this is the classification of systematic error. Okay. Now we will see in detail about the systematic error. Okay. So first we will see what is an instrumental error. Okay. So instrumental error means we know there will be error happening in an instrument. Okay. Why this error is happening means because of its mechanical structure. Okay. So you can use these springs or anything. So it will be getting, because of an aging process, it will be getting lose its property. So it will not show the accurate value. Okay. Due to the internal shortcoming in the instrument. Okay. That is an example spring. Okay. So the spring, because of its continuously operating, it loses its nature. Okay. So this is one of the things. The next one is fault of the operator. Okay, misuse of the instruments. Then loading effect. Improper use of instrument. Improper use of instrument means we know that this instrument will work under this condition, but we are overloading the instrument. Okay, if you are, for example, if you take an voltmeter, that voltmeter will measure up to 300 volt. Okay, but you are raising the voltage to 320 or 330. Okay, so you are overloading the instruments. When you are overloading the instrument, the error will be happening. Okay, due to the loading effect. Okay, this is the classification of instrumental error. Okay. Then environmental error. So we have already discussed. Okay, the instrument maybe we can do the calibration and we can reduce the error. Okay, even though we are reducing the error, because of environmental factors, we can find out some errors. Okay, so environmental factors such as temperature, pressure, magnetic field, humidity, dust and vibrations. Okay, so because of this environmental parameters, the reading may be changed. Okay. So for a particular instrument, they will be using a clean room. Okay. So where it is entirely cleaned, it is entirely closed. Okay. So it will not affected by any environmental conditions. Okay. So this is the environmental error. Then the last one instrument error is observational error. Okay. So what is observational error? You have already known. Okay. So while you are doing your high schools, you know what is that observational error. So the observation is nothing but a parallax error. Okay. So you only need to see the equipment. Okay. So where the pointer is. Okay. So you need to sit. You need to stand straight in the instrument, and then you need to take down the readings. Otherwise, there will be error with that. Okay. So you can see the image. Okay. So actually the correct reading is 250, but when you are pointing in crossword, the word voltage may be incorrectly reading as 249.5. Okay. So this is the observational error. Okay. Then the last one is random error. Random error is nothing but we can't able to judge. Okay. So by doing calibration, we can able to reduce the systematic error. By taking careful measurement, we can able to reduce the gross error. Okay. Even though I have reduced all the errors, okay, the instrument will process some error. Okay, we can't able to identify what is the cause. Okay, this is one random error or residual error. Okay. So this is the classifications of error. Okay. So we have quick recap what we have discussed. So we have discussed what is the functional element of an instrument. So what are the three components using for the functional element? Okay. Then based upon the function, we are going to measure the value. When we are measuring the value, what are the errors occurring? Okay. So we have seen gross error, systematic error, random error. So the gross error is due to the human mistake, and the systematic error is due to the system instrument which is going to measure. Okay. So not only an instrument, there will be an environmental factor will be also there. There will be an observational factor will be also there. Okay, this is the system error. And the last one is random error. So even we are doing calibration, the random error will be there. Okay, we can't know what is the reason. Okay, that is the random error or residual error. Up to this, we have got an idea what is measuring instrument, how we are going to measuring the data. Okay, how we are going to check the error in the data. Now we are going to see the instrument. So what are the measuring instruments? So the instrument is classified into two types. One is indicating instrument. Indicating instrument is it will indicate the value directly. For example, ammeter, voltmeter. Okay. The other one is integrating instrument. We know what is integration. It is an addition. Okay. For a period of time, it will measure the data. Then you need to do the addition. For example, energy meter. Okay. So it is for a total amount of electrical quantity supplied over a period of time. Okay. Example is energy meter. So energy meters normally will be calculated for a month. Okay. Or bi-monthly. Okay. So for a particular duration. Okay. The duration is the integration. Okay. Daily it will be added. Okay. From day 1 to day 30 it will be added, and then you will have your billing period. Okay. So this is the measuring instruments classification. So how this instrument is working? Okay, that is what we are going to see. The instrument is working based upon some essential torque. Okay, so normally this torque is classified into three types. One is deflating torque, controlling torque, damping torque. These are the essential torques used in the measuring instrument. So it's a very important one. Okay, so because of this three torque, the instrument is operating. So once again I'm repeating, it is an deflection torque, controlling torque and damping torque. Okay. Deflection torque, as the name itself indicates, because of the torque, the pointer will get deflect. Okay, so the pointer, how the pointer is deflecting? What is the principle used to make the pointer deflect? We can use different methods to make the pointer to deflect. We can use electrical field. Okay, we can use magnetic field, electrostatic field, any one method to make the pointer to move, or we can use temperature. Like there is a different parameter will be used to make the pointer to move. Okay, so that is the deflection torque. So deflection torque is used to make the pointer to show the deflection. The second torque is controlling torque. So what is the controlling torque? Okay, so because of some principal effect, the pointer is getting deflected. So it is deflecting. Okay, so it's showing some reading. Okay, so suppose after taking the reading, the pointer should come back to 0. How I am making the pointer to come back to 0? Okay, so for that I am using some controlling torque. Okay, so this controlling torque mainly provided by the spring gravity control. Okay, so the main purpose of this controlling torque is to bring back the pointer to 0. Okay, so you can able to see the deflecting torque, which is used to make the pointer to move, and the controlling torque which bring the pointer back to 0. Okay, so this is the main two torques. So then the another one important torque is that is damping torque. Okay, so what is the thing means you can able to see in the screen, there is a damping torque is there, controlling torque is there. So damping is from your it is coming from one direction, and controlling torque is applied in another direction. Okay, so because of these two torque, what will happen to the pointer? Okay, so there is a pointer is there, you are applying force torque from two directions. Okay, deflecting torque in one direction and controlling torque in another direction. What will happen to the pointer? Yeah, the pointer will start vibrating. Okay, it will not show accurately. The pointer will start to vibrate. Okay, I want to reduce this vibration. I want to damp out this vibration. For that, I am using the damping torque. Okay, so this damping also provided by different types of arrangements. Eddy current damping is there, air friction damping is there. So different types of damping is available. We can use based upon our necessity. Okay, so these are the fundamental torques. You can able to see in the next slide. Okay, so deflecting torque, controlling torque, and damping torque. So deflecting torque produces the pointer to move. So various effects, what we have discussed, magnetic effect, heating effect, chemical, electromagnetic, electrostatic, any one principle we are using here to make the pointer to deflect. So controlling torque, it should bring back to 0, and then also not to go to the pointer to an infinite value. So it is normally provided by the spring or gravity control. So damping torque, eddy current damping, air damping will be there. Okay. So these are the fundamental torques, okay, essential torques for an instrument, okay, to operate. So we are going to see an instrument, PMMC. So PMMC is the permanent magnetic moving coil. So how we are going to see this torques is available in the instrument. Okay, so if you take PMMC, this is an instrument. Okay, so if you open the instrument, it will be like this. Okay. So you can able to see two magnets, north and south. Okay, so for theoretical purpose, here showing the permanent magnet, but normally we prefer to use an electromagnet. Okay, so here there is two magnets, north and south. Okay, then there is a iron core is there. Okay, so after iron core, inside the core there will be coil will be there. Okay, so here you can able to see the pointer. Okay, then you can able to see the control spring, upper spring, lower spring. So this spring providing the controlling torque. Okay, and you can able to see aluminum former. So the coil is supplied by the aluminum former. This aluminum former will provide the damping torque. Okay, so when you see the instrument, you should write what are the things providing the essential torque. Okay, so the aluminum former provided the damping torque. control spring provide spring that is used for providing the controlling torque. Then which one providing the deflecting torque? Okay. So this permanent magnetic moving coil, the deflection is produced based upon the motor principle. So what is motor principle? When a current carrying conductor is placed in a magnetic field, it experiences a force. That is the motor principle. So here inside the aluminum former there is a coil will be there. So that coil will carry the current. So this current carrying coil is placed inside between the magnets. You can able to see the two magnets north and south. Okay. So between the two magnets, the coil will be placed in the aluminum former. Okay, current carrying coil. So when a current carrying coil placed in a magnetic field, a force will be exerted. That force is the deflecting force. The point will get deflected. Okay. So can able to see here. So the deflecting torque is K is equal to NBA. Okay. Deflecting torque is equal to Ki, where K is NBA. So NBA is number of turns in the coil plus density area of the coil. So here deflecting torque is directly proportional to the current. Okay. So then there is a different classification of instrument is there. Okay, moving ion. So if you see the moving ion, that deflecting torque is proportional to the square of the current. Okay, so for each instrument, it will be varying. Okay. So the control torque is provided by the spring control. The damping torque is provided by the aluminum for what we have discussed. Okay. So if you see the advantage of this instrument, okay, it provided a uniform scale, okay, because the current is directly proportional to the deflection. Okay, what amount of the current you are giving, that amount of deflection will be there. So the scale will be uniform. Okay, so you can use as an ammeter or voltmeter. Okay, by using a shunt and series resistance. Okay, so what is the disadvantage? Okay, in permanent magnetic moving coil, it is more expensive. Okay, it can be used only for measuring DC. This is an important point. Okay, it can measure only a DC, direct current value. Okay, it will not measure the alternating current AC. Okay, why it is not measuring the AC? Because AC is alternating, as the name itself is alternating. So it can't able to, the machine can't able to operate. It produces vibrations. Okay, so it can't read the value. Okay. So for that reason, this permanent magnetic moving coil only used to measure DC value, direct current. Okay. So how in previous advantage you can see the third point, it can be used as an ammeter. Current is to measure the range of current and voltage by using a shunt and series resistance. Okay. So the resistance is normally we will use the manganese. Okay, so it is an alloy. So we will be using this manganese as a resistive element. Okay. So if I want to use this permanent magnetic moving coil as an ammeter, I will be connecting this resistance in parallel. Okay. So here it is mentioned as SH. So SH means shunt. Okay. Normally parallel we will call it as a shunt. So if you are connecting a resistance parallel with the moving coil, then this instrument will act as an ammeter. Okay, which will measure the current. The same PMMC, if I am connecting this resistance in series, then it will be acting as an voltmeter. Okay. So here you can able to see RSC, that is series resistance. Okay. So based upon the resistance arrangement, it can use this moving coil instrument as an ammeter or voltmeter. Okay. So next we will move towards the digital meter. Okay. So why we are moving to the digital meters? Okay, we already have an analog meters. Why we are moving to the digital meters? So we have seen the error is happening. Okay, so we can reduce the error when we are moving to a digital meter. The response rate will be very, very fast. Okay, so when you connect the instrument, it will immediately show the response. What is the current value? What is the voltage value? What is the power range? Everything will be shown immediately. Okay, and you can take the backup also. Okay, so if you are note down any data, the data can be stored and used for further processing. Okay. So for further analyzing, we can able to store the data. That is the major advantage in digital meters, okay, which is not available in the analog meters. Okay, so it eliminates the observation error. So the parallax error will be reduced, speed will be increased, then memory will be there. Okay, what we have told. So we will see an example. Okay, so how the digital meter is working. For that we have taken the digital voltmeter. Okay. So digital voltmeter, we are measuring the voltage digitally. Okay. So there are different types of digital voltmeters available based upon what type of principle we are using. Okay. So one is a RAM type digital voltmeter, integrating type digital voltmeter, potentiometer type of digital voltmeter, successive approximation type digital voltmeter, continuous balance type digital voltmeter. There are different types of voltmeters there. Okay. So we will see the RAM type digital voltmeter. RAM type means here we are using the RAM type signal. Okay. So this RAM type signal will be generated by the RAM generator. You can see the RAM generator. This generator will generate the RAM signal. So we are applying the voltage which is going to measure. So the voltage is given to the ranging and attenuator. So what range we are going to give, and attenuator will be matching with the signal. Okay, so it will reduce the signal, it will match, and it will reduce the distortions in the signal. Okay, so this is given to the input comp. Okay, comp means comparator. Okay, so here there is a two comparators used. One is input comparator and another one is ground comparator. Okay. So comparator means it will compare. That is the main function. Okay. So you are giving the input voltage to the comparator, RAM signal to the comparator. Okay. So based upon when the RAM and input voltage coincide, at that point it will start the gate will be given. Okay. It will start to count. Okay. So when the RAM input voltage and RAM signal coincide, the gate pulse will be started. Okay. When it reaches 0, that is ground, it will give the stop pulse. Okay. Till the start will stop, how much pulses is received will be counted by the counter, and we can take down the readings. This is the working of RAM type digital voltmeter. If you see the image, you can clearly understand. Okay. So I am applying the voltage. Okay. So unknown voltage. Okay. So this straight line is the unknown voltage. Okay. This unknown voltage. Wait for a minute. So this is the unknown voltage. Okay. Unknown voltage. So I want to measure this unknown voltage. For that, I am generating the RAM signal. So you can able to see the RAM signal. Okay. So voltage RAM they have mentioned. This line is the RAM signal. Okay. So this RAM signal is generated by this generator, and it is given to the comparator. So the RAM signal is coming. So it is coincident at one point. Okay. With the unknown voltage. At this point, the pulse is started. So when comparing when it is coincide at that point, it will give the gate pulse. Okay. So the pulse will be start counting. Okay. So the RAM signal is traveling towards the ground on 0. When it reaches 0, stop pulse will be generated. Okay. So start pulse will be generated at the upper value, and the stop pulse will be generated at the ground value. Okay. During this interval, how much pulses is generated? Okay. So it is counted by the counter, and you can finally check what is the output voltage. Okay. This is one of the type to measure the voltage digitally. Okay. RAM type digital voltmeter. Next, multimeters. Multimeters means you can use the meter as a meter or voltmeter. Okay. Here you can able to see the various ranges will be there. Okay. Which is that what we have already discussed. The resistance will be connected in shunt. Okay. So the metering, if there is a moving coil, the resistance will be connected in shunt, and it is ammeter. If the resistance is connected in series moving coil, then it is called voltmeter. We can have various ranges. Okay. So previous slide we have seen only one resistance. Here we can able to see the multiple range of resistance value. So we can able to measure different voltage levels. So this is the multimeter. Okay. So up to this we have seen what is the indicating instrument. Okay. So first previous slide we have told that instrument is classified into two types. One is indicating instrument, another one is integrating instrument. Indicating instrument, we have seen the example ammeter, voltmeter. Okay, how moving coil is operating. Okay. Now we will see about the integrating instrument. Integrating instrument, the example is energy meter. Okay. Here you can able to see single phase energy meters. Okay. So what is the energy meter? Energy meter is mainly used to tell how much amount of energy we have consumed. Okay. So this energy meter, here you can see the diagram, constructional diagram. Okay, here there is three magnets available. One is M1, M2, M3. So based upon how we are giving the connection with the load. Okay. So first you can see M1 is the shunt coil. Okay. So if I am giving the connection parallel with the load. Okay. So this is the shunt magnet. Then this is the series magnet. So I will be connecting the coil in series with the load. So this is called series magnet. I am connecting this M1 parallel with the load. It's called shunt magnet. So these are the two magnets using. The last one is the M3. So this M3 mainly used for brake magnet. Okay. So brake which is used to slow down the rotation. Okay. So here there is an aluminum disc is there. The disc will be rotating. Okay. If I want to slow down or stop the rotation, I can use this brake magnet M3. Okay. So you can able to see this energy meter. So we are not going to go in depth of an energy meter operation. So we will give just a brief. Okay. So because it is a basics of engineering, so just we will give the basic concepts how an energy meter is working. Okay. So here you have two coils. Okay. One is M1, M2. Okay. So when the current is applied, we know that whenever there is a current, there is a magnetic field is there. Okay. So M1 will provide a magnetic field that is called phi SH, and M2 will provide a magnetic field that is called phi SC. Okay. So there is a two flux will be producing because of the interaction of the two fluxes. Okay. Because of the eddy current. Okay. What will happen? The center disk starts to rotate. This is the basic operation. Okay. So you are connecting the wires to the load. Okay. Or if you are connecting the load shunt, that is M1. If you are connecting the coil in series with the load, that is M2. Okay. So when you apply the current, flux will be produced. Okay. Whenever there is a current, it is surrounded by a flux. Okay. So when I am connecting to the current, flux will be producing. Shunt flux, series flux. Because of this flux interaction, eddy current interactions, the flux which produces eddy current, because of this interaction, what will happen to the disk? It will start to rotate. Okay. So based upon the rotation count, we can able to calculate how much of energy you are going to consume. Okay. This is a single phase meter operation. Okay. So there is a three torque is there. One is a rotating torque. So the rotating torque is mainly produced by the flux. Okay. So M1 produces phi SH and M2 produce the phi SC, series flux, shunt flux. Because of this two flux, rotating torque is provided. So the braking torque is provided by the braking magnet. So registering mechanism. The registering mechanism means how the disk is rotating. When the disk is rotating, it is connected to a counter mechanism. Okay, it will count how much rotations. Okay, based upon the number will be changing. There is the registering mechanism. So from the registering mechanism, we can able to calculate how much of energy we have consumed. Okay. So this is the disadvantages of an energy meter. So it will be an inaccurate. There is no remote monitoring. There is no viability of usage. Okay. So consumer can't able to know how much I have used for the particular instruments, or for particularly how much I have consumed. We have not a statistical data. Okay. So it is simply a one-way communication. Okay. So how much energy we have consumed, that is the one thing we know. Okay. So how we can overcome these disadvantages? Okay. For this, we are moving towards the smart metering. Okay. So you can able to see the conventional metering. The meter will be reading the data. It is given to the data center. Okay. In smart meters, there is a two-way communications. You can able to see. Okay. From smart meters, it will be connected to a home area network, and also it is connected to the database center. It is two-way communications, so that you can able to know what is your usage. Okay. So you can record what is the power quality of informations, just voltage, currents. Okay. So every period is recorded. Okay. It is a two-way communication, which will be very useful. So this smart meters is implemented in advanced metering infrastructure. Okay. So you can able to see here. Okay. This is the home. Okay. The home is connected with the smart meters. The smart meters is connected with various advanced infrastructure like home area network, wide area network. Okay. The different types of infrastructures will be there. Okay. Based upon this infrastructure, what is the benefit we are getting means we can manage the outage management system. Okay, we can detect the theft, tamper. Okay, then we can get an accurate reading. Okay, in a conventional meter, the readings is inaccurate. That's the main disadvantage. So here we can get the accurate reading. Okay. So then we can get the timely energy usage information. Okay, for a particular day, how much energy I have consumed, I can able to know. But in a ordinary conventional meter, I can't able to know. Okay, because here, how can I able to know the timely usage information? It's a bidirectional. It is giving the data. Okay, then more customer information for the utilities. So we can. It is a bidirectional, so that the supplier also will get the benefit. So when I want to give the maintenance or how much amount I want to generate more for in future. Okay, so he can able to calculate and he can able to start to work. Okay, so that is the advantages in the smart meters. So the smart meters is included in the advanced metering infrastructure. Okay, so that's all. So this is the reference from where we have prepared the CPPT. Okay, so before we move to the end, just we will have a quick recap. So what is we have discussed is we have discussed about the measuring instruments. So in that we have discussed about the what is the functional element of an instruments. Then we have discussed how the error is happening in the instrument. Then what is instrument, how it is measuring. Okay. So what's the essential torque for measuring in value. Okay. We have seen what is the regulating torque, controlling torque, damping torque. Okay. So we have same example for an instrument, that is for magnetic moving coil. Then we have moved towards a digital meter, how the voltage is measured digitally. And then we have gone through the integrating instruments, that is an energy meter, how it is work. So we have seen just a brief operation of a single phase energy meter. Okay. Then we switched over to the smart meters. Okay, so the main advantage we have switched over to the smart meters, it is a two-way communications. Okay, whereas conventional meter is a one-way communication. Okay. So this two-way communications will help in a lot of benefits will be there, what we have discussed. Okay, so the smart meter is implemented in the advanced metering infrastructure. Okay, where there is a lot of communication infrastructure network is there, like home area network, wide area network, neighborhood area network, different communication area network is there. That's the topic we have discussed in today's class. Okay, thank you.